Welcome in, Duffy. Hello, Brian. People are starting to get in. Hi, Kathleen. Hey, Dan. Good to see you. Hopefully, you guys can hear me all right. Uh, Everything coming through fine, Kathleen? I see you're able to post on the chat there. Awesome. Thanks, Brian. Hey, Hugo. Welcome here, Zach. If you get a chance in the chat, go ahead and tell people where you're from and what your job is. It's always interesting. Grab Mike's book here. Welcome in, Brandon. Hello, Danielle. Hello, Aaron. Hi, William. It's 10 o'clock here on the West Coast. We're going to give people a few minutes to assemble. Usually it takes a few minutes for people to work through getting signed on, get their speakers working, etc. Hey, Zach. Hey, Brad. Welcome in, Rachel. Hey, Lars and Lars. Two Larses in a row, both of which are trouble. Greg, boy, it seems like you would have had enough of me already, Greg, this week. But welcome here anyway. You're coming back for more. Hey, Justin. Good morning, Rachel. Hello, Jacob. Hello, Hannah. All right, we'll give people just one more minute to assemble here before we go ahead and get started, and the other people can trickle in as they get things figured out. All right, we're 4 over the hour, so we'll go ahead and get started here with, I'm sure there'll be more people coming in. Thanks for coming, everybody. This is a short webinar on fleet reliability. Today we're going to be talking about what it means to make your fleet reliable, what it means to keep it reliable, and what the implications of not having a reliable fleet are. The our uh, Our job today is basically to go through this whole topic from the perspective of the equipment manager. So the first webinar in this series was about your cost. This is fleet reliability. The next one's utilization. This one is really close to home for any of you guys who are the mechanics or the mechanic managers, people who are directly responsible for maintaining the equipment itself. I'm Michael Kelly here with a couple people from my office, Jackie and Josen. We are Silver Truck Systems out of Battleground, Washington, just north of Portland, Oregon. And we work in the construction accounting space in a number of ways, but especially with civil contractors. And equipment is kind of just a little baby of ours, something that we really like working with. We work very closely with Mike Forster. Mike Forster, some of you guys might know, he wrote this book, Construction Equipment Economics. He's a professor emeritus from Virginia Tech University and is well regarded in the industry. When he retired from teaching his certification classes, he asked if I would be willing to start teaching them. This is a number of years ago, and we've been teaching those ever since. We're writing a book together called The 10 Steps that's coming out this spring, and been having a lot of fun and got to know him and his wife. So I'm going to go ahead and share my screen. Oh, I guess a couple of notes, just housekeeping. This is going to be recorded and it will be sent out to everybody who registered. So anybody you would like to share it with afterward, feel free and do that. Also, there's uh, both a chat and a questions and answer section. Feel free to ask your questions in the questions and answers. Jackie's going to be monitoring that, and she'll jump in and interrupt me if one of the questions comes through that I can answer right on the spot. Feel free and put in anything you have there. We will have specific time for questions and answers at the end, but you don't have to wait for that. You can send them in at any time. Okay, with that, let me share my screen here and we're going to dive into the whiteboard. Here we go. All right. Okay. You should be seeing the whiteboard. Does that look good, Jackie? All right, perfect. So today we are going to be talking about fleet reliability, like I said, uh, and really this builds on the overall equipment philosophy that we have, that we've seen that has worked in world-class equipment management programs within construction companies. And I think it's worth repeating. I talked about this in the first webinar when we were talking about cost, but it's worth repeating that all of the work that we're about to talk about when we're talking about specifically reliability, it builds on this. The equipment philosophy that I personally subscribe to, and that you'll see in all of Mike Borster's work and all of the work that we do, is two parts. One, that equipment is a destructive means to an end. And what that means is that we aren't in business to own yellow iron. We're not in business to own a bunch of trucks. We're in business to get work done for our customer. Our customer doesn't care what we own. The customer cares if their work can get done. Our equipment is a means to get there. And in doing so, we're going to destroy that machine over the course of the life of the various products that it's deployed to. We're not in business to keep machines forever. We're in business to get the work done. And our job when we're talking about reliability is to keep the machines reliable enough that we can make them available so that they can be used up while creating the work. We are in business to create work, not in business to own machines. The second part of the equipment philosophy that underpins everything we do is that the equipment department inside a construction company serves operations. And this is important to note. The equipment department is a service department. What we're looking to do is we're looking to provide equipment to the operations because they're the ones who are out there making the money. And what we need to be able to do is provide the equipment effectively, and we need to be able to provide the equipment efficiently such that they can do their job well. We are not the primary revenue generators of the business, but we serve a critical piece that allows those people who are generating the revenue to actually go out there and do it. These two things are controversial in some companies. Both of these philosophies are controversial. To say that we're going to destroy our machines is not something that a lot of equipment managers want to talk about. The fact that equipment department serves operations is sometimes a little bit of a touchy subject. I'm not talking about some kind of like thing where the equipment department is less important than the operations. I'm just talking about the way that it works inside of of a construction company. This is the equipment philosophy that everything is built on. And how does this roll into specifically reliability? Well, when we get into reliability and we get into the reason we want to make our machines reliable, it comes down to two particular things. One, it's the fact that every down event is a cost event. Now, when I say a down event, what I'm talking about is a machine that goes down on the job. You guys are in construction. You have equipment that you use to build the work, and the machines go down on the job. The 2024 CFMA AEMP study showed that for every 1,000 hours worked, on average, across the United States for the the reporting companies, we're all construction companies, that there was 3.1 down events. For every 1,000 hours worked, there was on average 3.1 down events. So that means that every few hundred hours that a machine is on the job working, you guys are experiencing a breakdown of some sort. And a down event costs money every single time. And if that's true, then we need to, of course, reduce are down events if we want to reduce cost. One of our jobs in the equipment department, in order to serve operations, is to produce or to give these machines to operations efficiently. If we're giving to them efficiently, then we need to make sure that the cost is down. But it's, of course, a lot more than that. The second piece about reliability is that prevention is better than cure. If I can spell today. It There's a reason that you guys have a preventative maintenance program. You do your preventative maintenance such that the machines break down less often. It's cheaper to prevent a breakdown in the first place than it is to cure a breakdown after it's happened. We're going to be talking a lot about that today. That these are the two core pieces that you have to believe in order to believe the rest of what I'm going to say for the next hour or so. That every down event is a cost event and prevention is better than cure. We're going to talk about how these two things in reliability allow us to serve operations well and allow us to prolong the life of a machine such that while it still gets destroyed in producing useful work, that it gets destroyed in a managed way, and we can predict when it's going to start experiencing wear out failure. Every job, there's a kind of an old you can look it up on Wikipedia. I think it came out in the 1930s. A graph that is called the bathtub curve. And the bathtub curve just talks about the frequency of failure of a machine over time. And what you see with the bathtub curve is a curve that looks something like this. It's fairly frequent up at the beginning, it levels out, and it spikes up at the end. And there's three particular time periods. These are called infant failures. These are called the standard failures, and this is called wear out failure. Now, what we've seen in modern day is that our infant failures are not as much of a concern as they used to be. This period of time used to be a significant thing for all construction companies because what happens is that these infant failures, they roll off the line. There's a manufacturing defect, and we have to deal with them. We still have to deal with them, but a couple of things have happened in the modern age. One is that the prevalence of infant failures has come down overall. There's not as many manufacturing defects as there was in the distant past. The manufacturers are generally better at manufacturing high quality goods. The other thing is that we have a good, generally speaking, good dealer networks, and we have good warranty periods. And so even when they do have experience infant failure, that the dealers and the manufacturers are covering the cost of that. They're often even swapping out machines for us, et cetera, depending on the particular dealer, depending on the particular situation. So we haven't had to deal with this infant failure as much as it has been. The standard failures or the routine failures are the things that happen to any machine over the life as it's coming into its mature period. These standard failures can happen for a number of reasons, but these are things that just happen. It's essentially if you roll the dice enough times, eventually you're going to get snake eyes. So these things just happen over time. But these wear out failures are the ones that we really need to pay attention to. The wear out failures at a point in time, we start to see this curve go upward, and the frequency of failures goes up, and it makes it so that the failures are happening because the machine as a whole is wearing out. What we want to be able to do is start to predict these wear out failures before they happen and divest ourselves of a machine before we start to experience the wear out failure. This is what's called the bathtub curve. And this is in manufacturing, etc. This has been studied in many different ways. Certainly applies to our construction equipment. Now, the thing is that overall, like I said, we're serving operations. What we're trying to do is we're trying to make machines available, right? It's you go talk to the vice president of operations, you go talk to a project manager, you go talk to the CEO of a construction company, and he's going to say your main job, equipment manager, is to make machines available. And by available, what he means, what the I N I N E S. I knew I missed an I in there somewhere. Make the machines available. What they mean when they say make the machines available is they mean you have to have the machine on the job. The machine has to be working, right? We have to make it available. Well, the the problem is that we're not an airline. We're not the Department of Defense. We don't have to have make machines available 100% of the time. That's not the case. Now, airlines, when they don't make their machines available 100% of the time, it makes national news when there's a problem, right? We know when there's an issue with a Boeing in midair, right? That we know the Department of Defense can't afford to have their machines not work when they're in a combat situation, and so their requirement is to make machines available 100% of the time. But in construction, that's not the case, because what we find is that we actually don't have the capital, we don't have the resources to make sure that they're available 100% of the time. We say we're going to accept something lower than 100% of the time. And that means that we're going to accept a certain amount of breakdowns on the job. Now, people don't like to talk about that, but it is the truth. If we were saying that they have to be available 100% of the time, we would have to have many, many more mechanics, much bigger facilities. We would have to have much newer equipment. So, since it's not 100, the question is, what is it? How much do we need to have it be reliable? And, available? And in order to answer that question, we have to actually ask a separate question. What makes something be available in the first place? What predicts availability? Well, the equipment management folks learned a lesson from the safety managers. Safety managers, safety managers found out that it was very, very difficult to measure to measure the effect of a safety incident. So it was difficult to measure the effect of a safety incident. It gets into some sticky situations. Do we measure the effect of the safety incident based on the cost of the safety incident? Do we measure it based on what actually happened to the people involved? Right? Is it if somebody gets hurt minor? Is that less important that we track it down than a situation where somebody maybe breaks a leg? Right? It's difficult to measure the effect of the safety incident, and there was a lot of disagreement about this. Right? Some people were saying the only thing that matters is that we keep the people safe, the humans safe. Other people were saying, of course, we have to keep the humans safe, but we also have to measure the cost. How long is somebody out, for example, after they've hurt, maybe they've twisted their back? How long are they out and not able to come back to work? There was a lot of difficulty with measuring the effect of the safety incident. So what they said instead is, we're not going to measure the effect of the safety incident. We're going to measure and how bad each incident is. We're going to measure the frequency of the safety incident. Now, you'll see this, for example, here in Clark County. What if you go to the transfer station to drop off your garbage? What you see is a big sign out front that says days since safety incident, last safety incident, right? And then there's a number down here, right? And you hope that this number isn't zero. That they basically, what they're saying is, we're going to measure not how severe the incident is, but we're going to measure how frequently it happens. And by measuring the frequency and saying that over a period of time, say 1 year, if we see that the frequency of safety incidents is over the course of the year is going up, then we know we have a problem. And what we need to do is we need to make sure that if this pattern is happening, that we can reduce this trend in the next year. We're going to measure the frequency. We're going to say any safety incident is something that we need to deal with, instead of trying to go back and measure how bad it was, how much of an effect it was on the human, how much of an effect it was on the bottom line for the company, and getting ourselves into that. So in construction, we borrowed this and we said that we're going to also measure this. And instead of trying to measure availability, which gets into some weird situations where the machine goes down at 2 p.m. The guys were going to go home at 3:30 anyway. It was fixed by 5 p.m. Was it down for 3 hours because it took us 3 hours to fix it, or was it only down for an hour and a half because the guys went home at 3:30 anyway? Right? We get into some weird situations there. Um, the Instead of measuring availability, instead of measuring the effect of these down events in terms of how long it was down, let's just measure frequency. This is much easier. Let's just measure instead how often these things happen. So how do we measure the frequency of down events? We simply say, we answer this simple question. Did the machine go down? Not due to abuse. Did the machine go down? Not due to abuse. In other words, was there a red event? Now, a red event is what's a backronym that we use that is reported emergency down. Reported emergency down. Did the machine go down on the job, not due to abuse? If it did, then that's one event. Now, that might have gone down on the job and you might have been able to fix it 15 minutes later because the mechanic was already out there doing something else. That might have been something that went down on the job and it was a significant problem that required that machine to be hauled off the job, possibly even causing damage to the job itself, and you had to get a new machine out there and get this thing fixed. Might have caused massive delays. In both cases, it's one red event. Did the machine go down or did it not? So we need to be able to measure this. Now, what we can do then is we can start to say, if we measure these red events, we can start to find out how many red events per 1,000 hours worked. And this measurement right here, red events per 1,000 hours worked, allows us to set a standard for our company, for our fleet, and for each category of machines. How many red events do we call acceptable? And if our red events per 1,000 hours worked over the course of a year is going up, then I know for a fact that our availability is going down. And if our red events per 1,000 hours worked is going down over the course of a year, I know for a fact that our availability is going up. So red events per 1,000 hours is a way for us to measure reliability. Are the machines reliable? Is our fleet reliable? Are we, as a mechanic group, doing what we need to do to make sure that our machines are reliable? Is it within acceptable boundaries? And if it is, then we are answering the question that the CEO has for us, which is, are you going to make my machines available to work on the job? So this is a simple question now. Did it go down? Not due to abuse. It's yes or no. We don't have to answer the question of how much it costs to fix it. We don't have to answer the question of how fast we fixed it. We just have to simply answer the question about whether it went down. We just need to measure that. So one of the things that we talked about earlier was that we know that every down event is a cost event. It's kind of interesting if you look at the cost per hour, the cost per hour of a red event from the time that the event occurred, the incident, to the time that it was resolved. What you find is that the cost per hour for a red event is actually significantly high at the beginning. And this is due to the chaos. The chaos that ensues after the red event when you know and of course we've all seen the kind of the catastrophic things, right? The crane lowering the D8 down into the pit, and the crane fails and the D8 tumbles down into the pit, right? We've seen these catastrophic failures, these kind of things on YouTube. But even in a smaller way, even if it's just your foreman's pickup truck that breaks down, and now he has to pull over to the side of the road and get a tow truck and find some other way to get to the job, right? We have this chaos that ensues in the immediate aftermath of uh, the incident happening. Then it settles down somewhat for a time until the resources can be reassigned. And this is usually reassigned in a number of different ways, right? On-site superintendent is saying, "Hey, well, if the loader's down, let's go ahead and work on a different part of the work. Um, if our if we can't use the excavator, then let's go ahead and finish out the grading over here. We'll reassign the workers to do something else. Sometimes it's a matter of getting another machine moved out there and using the other machine. Or once our reassignment cost goes down significantly, and then the only cost that we have is for the repair itself, right? And then once it's actually resolved, that cost finally goes down to zero. This is the typical cost per hour that you'll see for a red event. Now, what about an event that you anticipated happening? Let's just say that you have a good oil sample program and you were able to see, because of the particulates in the hydraulic oil, that you had a problem. You were able to diagnose the problem effectively, and you were able to solve the problem early on. Maybe you had to replace the hydraulic pump, right? Maybe there was enough damage in the hydraulic pump that it was getting stuff into the hydraulic oil, and that was going to cause problems all over. And you were able to see that through your standard hydraulic oil sampling program. What does the cost per hour look like for that? This is what we call an orange event, right? And our orange event is something that a condition-based maintenance. The the condition-based maintenance is where we say the condition of the machine let us know that we need to do something. What is the cost per hour? Well, for one thing, we don't have any chaos. For another thing, we don't have to work. We don't have people wandering around the job waiting to be reassigned, and we're also usually able to do it in a controlled environment and do it more quickly. So, from the time of the incident to the time that it was actually resolved, a condition-based maintenance cost per hour looks something like this. You have the repair cost only. All of the cost of a red event that wasn't able to be predicted and what caused it to go down in the field, the area of the red above the area of the orange there is extra cost that we see because of it being a down event. It's that cost that we want to avoid. It's that cost that allows that the digging into reliability allows us to avoid by making it more often a condition-based maintenance. So how do we do this? Well, let's think about the timing of the actions. When I say an action, what I'm talking about is this repair. because it isn't the case that we're going to be able to run a construction company without repairing our machines. That's just not happening. You're going to have to repair the machine. Not only are you going to have to repair the machine, but you're going to have to do things like oil changes, right? You're going to have to end up doing brake. You can change the brakes. You're going to have to do things that are standard maintenance on all of these machines. You're going to have an incident, or you can say something that you're doing on the machine. But these don't come in they're not all the same. The uh, in some cases, you've been able to avoid failure. And in some cases, you had to fix it after failure. Sometimes you were able to have a good oil sampling system and program, you were able to catch the hydraulic pump was bad. Sometimes you weren't. And so therefore, after the hydraulic pump went out, you actually had to go and fix that after it failed. Also, there's times where the signs of failure are easy to see. And there's times where the signs of failure are hard to see. Now, when we talk about this particular graph, when we're in our boot camp, what we do is we have people talk about the most a red event that they've had recently. And oftentimes, what we find is that the red events that they've had recently are things that are relatively hard to see, things that have happened to their machines that really there's not much you can do to actually uh, prevent that without significant rework. For example, one of the equipment managers that was in one of our boot camps said that they had a wiring harness fail, and because of that, the truck, which in this case was a large semi, ended up breaking down on the side of the road. The wiring harness was somewhere that you couldn't get to easily. They didn't know it was wearing out. Something had broken on it, and because of that, they ended up having to tow the machine back and find the electrical problem and fix it. It was difficult to find that, so therefore the machine was fixed after failure, and the signs were hard to see. These kind of things happen all the time, right? These things are what we have in the construction industry, and we accept as a part of business. Now, earlier on, I said that the national average of down events, at least in the 2024 survey, was 3.1 red events per 1,000 hours worked. That means that you know the people who are going in to look at the CFMA numbers, who are contributing their numbers, who are tracking their down events, who are running these businesses are not stupid people. These are people who are running successful businesses that are trying to get better. Why would we have any red events at all? It's because of this, that the signs are hard to see and we accept them as a part of business. We say these things are going to happen. We just want to have them happen as infrequently as possible. But every now and then in our boot camps, we find a fix that happened after failure, in other words, a down event, where the signs were easy to see. In this case, the downtime was unnecessary. And when our downtime is unnecessary, the When our downtime is unnecessary, that means that we've wasted money. We've wasted exactly this much money up here, all of this red area above here, the cost per hour. Our downtime is unnecessary when the signs are easy to see. Oftentimes, this is a failure of on-site supervision, a failure of on-site inspections, right? So if you have an inexperienced operator and they don't know or aren't trained to do to inspect their machines as necessary, then the they something might be failing. It might be obvious to somebody who has more experience, but they don't report it back. Sometimes this happens where they do report it back, but because of some failure in communication, it doesn't get to the right person. And of course, there can be a million other things. But if we have a red event where the signs were easy to see, that means the downtime is unnecessary. Now, what kind of failures do we have where we're able to avoid them? Well, if the signs are easy to see, and we've managed to avoid the failure here. This is exactly what I was talking about with the condition based maintenance. And condition based maintenance is the cheapest type of maintenance you're going to do. This is the kind of thing where you have a mechanic go out and inspect the machine. The mechanic says this part is likely to fail. Because this part is likely to fail, we're going to replace it, and we're going to replace it before it failed, and we're going to save ourselves the downtime. These are things that are easy to see, that we can inspect, that we can and we can fix. The things that are hard to see and yet we are able to avoid them. This is our preventative maintenance program. Whoops.
Hey, Michael, we have a question if you have a second.
Yeah, go ahead.
It says that you mentioned a survey. Could you share more about that survey?
Oh yeah, absolutely. The survey that I was talking about is the CFMA. I can pull it up here. The CFMA heavy equipment comparator. CFMA heavy equipment comparator. Um, I'll pull it onto my screen here. This is the survey that gets put out every year. It's a cooperation between the Construction Financial Management Association and AEMP. And there is, yeah, you can go in here. If you when you submit this, you actually get to see. So you submit your own information. There's some you can purchase it, so you can purchase the results from other people. If you submit it, I believe that there's some kind of discount. So if you give your numbers, then you don't have to pay as much. I think that that's how that works. But this is CFMA's comparator. They try to get companies, they do get companies from all across the United States, especially people who are in civil mining and that kind of thing, to be able to look at this. All sorts of different benchmarks in there. So the other thing that when you look at this little graph, what you can start to say is, what do we need to do to spend less money? What do we need to do to make our fleet more reliable? Well, in general, what we do is we want to move things from the fix after failure to avoid failure side of the line. And as much as we can, we want to make things that were previously hard to see easy to see. So, for example, one company I work with has, because of their oil sampling program, they are now able to see things through both the oil sampling and the training of the technicians to actually read the oil sample reports that previously they accepted as a part of business. Through operators actually inspecting and being trained to inspect the right things on their machines, the things that were previously hard to see, at least from the perspective of the shop manager, are now easy to see because they're getting reports back from the operators on a daily basis. where the walk around report is no longer something that is only strictly about safety and making sure that the machine is safe to use, but it is now also about whether the machine is going to break down in the near future. We have people uh, who have seen that a fix after failure is no longer good, so they're going to avoid failure by increasing the preventive maintenance program. One of the most significant things that I've seen done now is related to emissions. All of you guys who are on here probably are struggling with emissions in one way or another, and we've seen companies who have started to say we these particular parts, say in a like Cat 320 size excavator, the emissions system breaks down at 6,000 hours on average. Therefore, we're going to replace it at 5,000 hours. This is preventive maintenance. In some cases, they might be replacing a perfectly good system, but they know that it's going to cause problems on average in another 1,000 hours, so they're going to replace it now. That's what we're doing with our preventive maintenance when we're talking about our oil changes, when we're doing the things that we know we need to do, because uh, it's going to fix the things that are hard to see, but it's going to make it so that they last longer, the machines last longer in general. Every time you have a down event, you can start to ask yourself why you had that down event. And you can ask yourself, was the down event something that happened here because it was unnecessary, in which case, how do we prevent that from happening? Or was it something that we're going to accept as part of business? And if we are accepting it as part of business, is there a way that we can in the future no longer accept this as part of business? In other words, no longer have to accept this as part of business by making it part of our preventive maintenance program, by making it something that we can actually inspect. Example of that was uh, a, one of the mechanics had went and bought I wish I remember the name of it, but it was a small ultrasound machine that from Harbor Freight, $80 tool or something like that, that gave the depth. That they could actually get the depth of the undercarriage, and they could figure out how much time, how much life they had left on their undercarriage without actually having to pull it off and measure it. They also didn't have to buy Caterpillar's, white labeled machine for $800 that did the same thing. They were able to make that condition based maintenance by inspecting it. Um, are we able to move that over so that we can avoid the failure, and are we able to move it up such that the signs are easy to see in the future, with the overall goal of making sure that our red events per 1,000 hours are going down? One last thing that I'm going to say before I turn it over to you guys for questions, and that is, how do we measure these in the first place? And I think that if you're not already doing it, you need to start a work order system. Now, most of the programs out there have some sort of work order system built into it, right? You can do it inside of Viewpoints Vista, you can do it inside of Tenna, you can do it inside of Equipment 360. In your work order system, inside of your management system, you should be able to build a work order system. A work order system basically just takes all of the work that you're doing for individual pieces of machinery and consolidates them into one thing. It puts it in terms of over time, instead of all of the costs just kind of putting into the same bucket and saying all of this bucket is for my excavator. Let's just say it's a Cat 320, and that we have no differentiation between all of the costs that went to our Cat 320, but now we can start to tag them and say that it puts it in chronological order, all of these work orders, what happened, and we can find out why they happened. We recommend specifically color coding your work orders, that you color code them in a way that is obvious to everybody. We've already talked about the worst one, right? Which is our red work orders, right? Where we tag a work order and we say this is red, this is a down event. We also use black. This is for the abuse. And this is another one that I find to be really critical when we're talking about reliability. because we shouldn't be talking about the abused machines as an example of a down event, or saying that we have unreliable machines, but we certainly need to deal with the abuse. It's our job as equipment management professionals to both repair the abuse after it's happened and also train the operators such that the abuse doesn't happen again. But this black event, something that happened because, you know, because the operator didn't know better or because there was something going on, that is not counted against our reliability. We don't have an unreliable fleet because of the operator necessarily. So we want to carefully differentiate between those. Also, generally speaking, this is getting more into the cost side of things, but I recommend that the job itself bear the cost of the abuse, not the equipment department. Then we have uh, our uh, our yellow work orders, and our yellow work orders is the routine replacements that you can plan. Undercarriage repair is a good one. Tires is another one. Any ground engaging parts. We have our orange, which is our condition-based maintenance, which we've talked a lot about. We have finally our gray. Hard to see on this. It's almost too not dark enough. Um, our gray work orders, which are our capitalized repairs. Capitalized repair is any repair that extends the useful life of the machine, something that we're going to put on our assets, and we're going to say that this is, you know, a full rebuild, that kind of thing. Capitalized repairs. So all of these are standard ones, and then if all of the preventive maintenance work that we do are green. Oops. Preventive maintenance are green. If we have a work order system that says we're going to do something, everything that we're going to do, every incident of any kind, anytime we're touching a machine, it should have a work order. Every time that we have a work order, we should have a color coding system where these things can be color coded, and we can say, well, the reason that we're touching this machine, the reason we're spending money is because it's preventive maintenance. The reason we're spending money is because it was abuse. The reason we're spending money was because of something that came up on an inspection report, and that allows us to tag all of these things. If we have a robust work order system where every time we're working on anything, we have it coded to a work order and not directly to the machine, or heaven forbid, not coded at all, that we have the ability then to go back and look and say, how many red work orders do we have? How many times did we touch this machine because the machine was down? And if we look at this CAT 320 and we see that there was 5 work orders and 2 of them were red events, that means we simply have 2 red events. We can say how, if we have 2 red events, how many hours did we spend from here to here? If there was 1,000 red events, that means that we have 2 red events per 1,000 hours on this machine. 2 red events per 1,000 hours on this machine. If we zoom out and we do this for all of our machines, we can actually get this for our fleet. We can start to say, how many red events did we have over the last month, over the last quarter? Because anybody who's worked in construction, especially in the northern latitudes, knows that this is cyclical. You're going to have more red events in the summertime if you're a seasonal business, because you're working more hours. Everybody's working more hours, therefore the machines are going to go down more frequently. Just because the machines go down more frequently does not mean that you're doing a bad job as an equipment manager, because you're also putting more hours in the machine. The only way to know whether or not this is going up or down is to say how many per 1,000 hours worked. And now we can say, was there more or less in the last 3 months than what we're used to? All of you should know, you should be able to know how many red events you're comfortable with, right? One way is think back in the last 3 months. Did you guys, from your gut feel, did you have too many red events? And I'm not saying not saying like in the abstract. I'm not saying that any red event's a bad event, so therefore we shouldn't have had any. Because that's nonsense. You're not the Department of Defense. You're not the Alaska Airlines, right? But over the last 3 months, did you have an acceptable number of red events? If the answer is yes, then go calculate how many red events did you have, and calculate how many hours did your machines work. There's your new target. There's your new baseline. Now, I'm not saying that that's a perfect baseline. I'm not saying that that's exactly what it should be, but it gives you a place to start. If the last 3 months were, hey, we did all right. It was okay. It didn't feel too crazy. We only had that one big thing. Well, then set that as your baseline. Now you know how many red events per 1,000 hours that you should have, and then you can look back and say, are we still following that? The other important thing is that if we go back to what I said originally with the bathtub curve, right? And we talked about this section of time where we have the wear out failure. What we'll see is that the red events per 1,000 start creeping up because we end up with these red event work orders in this time, and they come of course more and more frequently as we get higher and higher on this particular graph, right? This is the number of failures, and this is time. And what happens also is that because each of these red events is a cost event, every down event is a cost event, each one of these things costs money. And how many times have I heard a construction company owner say, we've spent so much money in the last year that we could have bought a new machine. We need to get rid of that machine. Now, that's correct, but it's too late. What if we could have used the frequency of red events and the fact that at this time it was already above and beyond our what we're okay with, to predict that it's going to be worse in the future, and say that because we've experienced red events per 1,000 hours that are above what we're comfortable with at our company, that it is time to divest ourselves of this machine right here. And now we will have avoided this cost because we predicted it, because we're going to experience wear out failure. Wear out failure is going to continue to get worse. Because we've predicted this, now we've avoided that cost. We don't have that same conversation, and we've prevented the problem in the first place. So if we can just track our down events and we can normalize them using 1,000 hours worked, we can both use it to say, are we doing a good job as a mechanic shop fleet-wide? Are our red events per 1,000 hours low enough that we are providing available machines to the operations whom we serve? And we can predict, because of rising red events on individual machines, that we're going to have additional wear out failure and wear out cost in the near future, and we need to divest ourselves of that machine. Okay, that's it. I'm open for questions.
We do have one more question in the chat, Michael.
Okay, let's see here. Condition-based, would that be deficiencies reported? Yes, Hugo, that's a great question. That is deficiencies reported. So those are things that the people in the field have reported that need to be fixed. These aren't necessarily things that you have a wide range of operator inspections, but these are deficiencies reported. Oftentimes, people will have both an operator inspection and a mechanic inspection. Sometimes people have a fueler's inspection as well. And those are the things that you repair because they were reported before it went down, before it failed. Good question. Other questions, please feel free and put them in the chat. We also, I just want to bring up, we have the third series of this webinar coming in April 14th. That one's going to be on utilization. Good to have the operations folks at that. That is on April 14th, webinar number 3 in this Yellow Iron Black Smoke series. And of course, our first 2026 cohort of the equipment boot camp, when we go through the whole textbook of Mike Vorster's, that in-depth class for 9,500 for 3 people from your company. That is starting in June 25th and 26th is the first online meeting for that, remote meeting for that. There's still room in that class. Happy to have you guys come to that.
Michael, there's one more question before we jump off.
Yeah. Brad, do you look at trucks on a per hour or per mile basis or both? Excellent question. Most on-road vehicles we look at on a per mile basis, not per hour. The exception to that are machines that idle for long periods of time. For example, you get this with like digger derricks, or you get it with bucket trucks for linemen, where the per mile is not as indicative of wear out failure as the per hour. However, like for foreman trucks or for on-road vehicles, personal vehicles, etc., those ones you would use on a per mile basis. And so you do red events per, and I usually use 10,000 miles. So red events per 10,000 miles driven. Okay, cool. Well, thank you guys all for coming. I'll hang out here if anybody has any final questions for the next few minutes. But I appreciate you guys taking the time today and spending the time to learn about this. Hopefully you guys can sign up for the next utilization webinar. Happy to have you there. And we will see you in the future. Huh, that's great, Justin. I see that you're saying you're right here in the Hawkinson area. Yeah, you'll have to come by. All right. Great. Thank you, everybody. Thank you, Kathleen. Appreciate it. Hopefully this was helpful. See you later, Lars. All right. The recording will be sent out, and everybody have a nice day.